domain and range from the graph. And it's great. You can take your pencil and, box it in and say, hey, what's going on? And it's real visual. Okay. Today we're going to talk about, it's 12. Today we're going to talk about 4 special functions that it's a lot easier just looking at the equation. All right, and most of the time that's all you have. And these are some 4 special occasions that's all we have. Okay, so to talk about the 4 different functions that we have, we're going to use what's called a parent function. Anybody know what a parent function is? Any idea? Have you ever heard that before? Okay. I don't think you probably have. So, all right, a parent function. Okay. It's like the base of a graph. Okay? So, for instance, on A, what kind of function do we have? What is it? Yeah, it's linear. Okay? And the parent function is y is equal to x. All right? All parent functions start at the origin because it's where it all starts. Okay? And y equals x is just going to give us the slope of 1 in a straight line, right? Now, if I have y equals x, and if I had, let's say, y is equal to x minus 3, all that does is it moves it down 1, 2, moves it down 3, right? And if the slope, we change the slope, it just takes the parent function and it adjusts it based on what the slope is, all right? Does that make sense what a parent function is? Okay, so what do we know about a linear equation in regards to the domain? What's happening to my x as I come from negative infinity? Okay. What's my domain going to be? Yeah, it's always going to be negative infinity to infinity. Remember when we talked about yesterday how, what am I trying to spit out? Like a linear function is the definition of a function. It's one input, one output, and it's always going to be hit all real numbers. So that means since we have one input, we always get the same output or one output, the range is always infinity, okay? And it's always, okay? So if I said to you, what is this equation? You could say, you don't even have to look at the graph. You could say, hey, that's a linear equation. Domain and range is always all reals. Okay? Does that make sense? All right. What about B? What kind of function's B? You may know what that's called. Do you know what the graph is called? Because the graph has a different, huh? Yeah, the graph is a parabola. Okay. And it's called a quadratic function. Remember when you were factoring back in Algebra 1 and you used the quadratic formula? Remember that one? Plus or minus b, or negative b plus or minus square root of b squared minus 4ac over 2a. Remember that one? Kinda? You all look like your heads just exploded. Okay? the quadratic formula, it got its name because it works on quadratic functions. All right? And its parent function is always y is equal to x squared. Okay? And if we look at our domain, what is going to happen? As we're coming from negative infinity, are we going to negative or to infinity? As they go up, are you ever going to stop? Mm-mm. So your domain is always negative infinity to infinity. Okay. Now, let's look at the range. If I box it off there, where am I starting at? I'm starting at 0, because remember I said all parent functions start at the origin? But it's going up the y, it's going on forever, and it goes to infinity. Okay? Now, remember when we had, let's say, if we had, would it look like if you had y is equal to like x squared minus 3? What's that negative 3 represent? Yeah, it's basically your y-intercept. So that one, you'd come down to negative 3 and draw your parabola, okay? So where would my range start then? That would start at the negative 3 then, right? Okay, so we can say your domain is always negative infinity to infinity, but the range will change depending on the y-intercept. And what else? If I had one that was a negative x squared, where now my range is going to come from here, and now I'm going to be going, let's say this is 2, I'm going to go to a negative infinity. Okay? So it depends on your y-intercept, and let's see, how do we want to say that? What do you want to call that? I want to say the position, and I don't want to say the upside down, and because that's your parent, and then y is equal to negative x squared. Since it's negative, it gave you the frowny face. Remember that part? So position of the graph. Okay, so it's always going to be your y-intercept and your infinity. Just depends on whether it's positive infinity or negative. Does that make sense? All right. What graph is that? Anybody seen that before? That's okay. I don't necessarily expect you to. That is the square root function. Okay? So your parent function is y equals the square root of x. Where does my domain start? I'm coming along from my x. It starts at 0, right? And where's it going to go to? So I go along the x-axis. It's going to go to infinity. And if I go up the graph on the y, it's the same thing. I start at 0, and I'm going up to infinity, right? So that means my domain and range will stay positive. And think about that. That kind of makes sense because what's the square root of 9? Plus or minus 3, right? I'm good with that. What's the square root of negative 9? Can you take the square root of negative 9? Because square root of 9 is 3. Positive 3 times a positive 3 is positive 9. Negative 3 times a negative 3 is positive 9. I can't get to that negative 9, right? That's why the domain and range will stay positive. Okay? And actually, third quarter, I'm going to show you how you really can because we have imaginary numbers, but for what we're doing now. Domain and range has to stay positive. That means our x's have to be greater than or equal to 0. Okay, can't have an x less than 0. Alrighty, my last one. What's this weird looking thing? Anybody know what that one's called? We will do a lot with rational functions this year. Okay? They're also called inverses. We're going to do a lot with those. And our parent function is a fraction, 1 over x. Now, reading this graph can get kind of tricky. You have to think about what's going on. I'm coming in on my x's, and I'm running along, but then before I get to 0, I just head down. All right? So on the number line, if I was graphing the number line, I'd be coming along negative infinity, and then I skip 0, and then I pick back up and come along and keep going to infinity. So it's like I jump 0 and I go to infinity. Okay? So there's two ways to write this. We could do it in interval notation, but I have to basically say it's every number but 0. So you have to say from negative infinity to 0, and U for union, so and from 0 to positive infinity. But this is why I like set builder notation. I can just say, hey, all of x such that x can't be 0. Much easier to write, I think. All right, so the big thing is that you can't have 0 in the denominator. Why can't I have 0 in the denominator? It doesn't touch 0, but just thinking about in general, can you divide by? You can't divide by 0. Okay? That's that bad rule. Can't do it. Okay, so thinking about all these 4 that we just talked about, looking at the equations, what's the difference between x and x squared? The exponent, right? This is the exponent of 1, that's the exponent of 2. That technically is an exponent of 1/2. So you just look, when you're looking at the equation, just look at what's going on with your x, all right? These are all pretty simple. It's all reals, always, 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 domains, always, 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 all. It's these two that have the special rules, right? Okay, that's why we like to use the equations, because it's easy to do. We need to look at the square root and the rational, because it actually is easier to solve from the equation than looking at the graph. Okay, so on our square root function, okay, that was the one that looked like this. And we said that it can't be negative. We can't have a negative. So we have only positive numbers, and the x falls under the square root. Okay? So that means that our x's have to be greater than or equal to 0. Good? All right, so set, it's called the radicand. So, but basically that's what's under the square root sign, greater than or equal to 0. So I have x minus 6 is greater than or equal to 0. Okay? So that means when I solve, x has to be greater than or equal to 0. And that means that my domain is going to be from 6 to infinity. Okay, good. All right, let's talk about the rational function. Okay, that was our y equals 1 over x. Oh, somebody said, Anna said, you can't divide by 0, right? That means I can't have 0 in the denominator. So, never in the denominator. Denominator, I can't spell it. Okay? So, that means to find my domain, I set the denominator so it can't equal 0. My function is x plus 3, so x plus 3 cannot be 0. That means that x cannot be negative 3. So in my set builder notation, I can say, hey, x, all such that x just can't be negative 3. Okay? All right, now I gave you a practice paper for problems, but we're almost out of time. So I want you to do the example 4 and example 5, those 6 problems for your homework tonight, and then we'll go over and do them tomorrow, because example 4 is going to be just like example 2. Example 5, you're going to do just like example 3. And then after we get done with those, we'll do a work day where we're doing practice stuff in class kind of thing. Okay? Sound like a deal?